Welcome back to section 2.4. We're talking about complex numbers. With complex numbers, that's when we have our imaginary unit, I. And I is the square root of -1. And keep in mind, I squared is -1. So I equals the square root of -1, and I squared is -1. That's really the key for what we're going to be talking about in this section. So a complex number is in the form of a plus bi. Now, in that, a is the real number portion, and bi is the imaginary portion. So we have the real part, a, plus the complex part, bi. A is real, b is the imaginary, that complex part. Now, adding and subtracting of these complex numbers, you can look through that. Additive inverse, when you add 0, it doesn't change your number. When you add the opposite, whenever you add opposites, you get 0. So what we're going to do is we're going to add, subtract, multiply, do all those operations we normally do. So to add these, just get rid of the grouping symbols. 4 plus 7i. Distribute the 1, we get plus 1 minus 6i. And now combine your like terms. 4 plus 1 is 5. 7i plus -6i is plus I. There's our complex number, 5 plus I. That's it. That's all you do. So now, get rid of the grouping symbols, 1 plus 2i, and be careful, distribute the negative, -4 minus 2i. So we combine, 1 minus 4 is -3. 2i plus -2i, they cancel. We're left with just -3. Number 3, we distribute the negative. So 3i, distribute the negative, you get plus 2 minus 3i. Distribute the negative, minus 2 minus 5i. Combine, 2 plus -2, they cancel. 3i minus 3i is 0. Minus 5i, we end up with a -5i in the end. Get rid of the grouping symbols, 3 plus 2i plus 4 minus I. Distribute the negative, -7 minus I. And we combine our like terms. So now, 3 plus 4 is 7 minus 7. All the constants cancel. And it's 2i minus I minus I. So the imaginaries cancel. We're left with just 0. After all that, we just got 0. Next page. Multiplying of the complex numbers. So keep in mind, I squared equals -1. So we just multiply. 4 times -2 is -8. 4 times 3i is plus 12i. And that's it. And we want to keep these in the form of that a plus bi in the end. Distribute the 8i. 8i times 4 is 32i. 8i times -3i is -24i squared. Now, I squared is -1, so we have 32i minus 24 times -1. We want the real portion first. -24 times -1 is 24 plus, and then our 32i. That's our answer in that standard form. Multiplying just like we multiply binomials. 2 times 4 is 8. 2 times 3i is plus 6i. Distribute the -i, -4i, and then -3i squared. Now remember that I squared is -1, so it's 8. Combine the i's, we get plus 2i minus 3 times -1. So -3 times -1 is positive 3 plus 8. So we get 11 plus 2i in the end. Number 8, 3 plus 2i squared. If you remember the pattern, a plus b squared, you get a squared plus 2ab plus b squared. Or you can write this twice. I'm going to show you the shortcut. Square the 3, you get 9. Square the 2i, you get plus 4i squared. And the middle term is 2 times 3, which is 6, times 2i is plus 12i. Remember, I squared is negative 1, so it's 9 plus 12i plus 4 times negative 1. 4 times negative 1 is negative 4, and negative 4 plus 9 is 5. So you get 5 plus 12i for your answer. Distribute for number 9. 3 times 5 is 15. 3 times 4i is plus 12i. Distribute the negative I, you get negative 5i minus 4i squared. So we combine, we have 15 plus 7i minus 4, and I squared is negative 1. Negative 4 times negative 1 is positive 4. So 15 plus 4 is 19 plus 7i. And you can see our answer is in that standard form, a plus bi, the real, then the imaginary. Here we multiply. We have 9 minus 6i plus 6i minus 4i squared. So we have 9. The i's cancel. Minus 4, and I squared is negative 1. And 9 plus 4 is 13. Interesting. Now, what we had there for problem number 10 is our next portion, complex conjugates. And we talked about the conjugates, a plus b, a minus b. Now, complex conjugates, they just have that imaginary portion, the I. So when you multiply these, when we multiply conjugates, the middle terms cancel. You get a squared minus b squared. Now, for the other one, you get a plus bi times a minus b. That's the same thing. It's a squared minus b squared. So in this case, the way it works out, and we'll see this, is it becomes a squared plus b squared. Don't worry about that too much. We'll see how these work. So we're going to look at complex conjugates. 4 plus 3i, the complex conjugate, 4 minus 3i. 5 minus 2i, the complex conjugate, 5 plus 2i. For 8i, the complex conjugate is a negative 8i. Now, one thing I want you to notice is when we multiply these complex conjugates, we end up with just a real number in the end. That's a key. Because now we're going to be simplifying when we have division. So we're just going to do 14 and 16 and then come back and talk about the rest later on. So now, to get rid of the I in the denominator, to get rid of it, we have to multiply by the complex conjugate. And the complex conjugate of 4 minus 2i is 4 plus 2i. And you'll see what happens when we multiply. So we multiply in the numerator. We're going to multiply the binomials. You get 8 plus 4i plus 12i plus 6i squared. And in the denominator, we end up with 16. I'm just going to do this once. Plus 8i minus 8i minus 4i squared. You can see in the denominator, the i's cancel. Now in the numerator, we have 8 plus 16i plus 6 times negative 1. And in the denominator, we have 16 minus 4 times negative 1. So 8 plus negative 6 is 2 plus 16i over, and it's just going to be 16 plus 4, which is 20. We have no more I in our denominator. Now, the next thing we want to do is split them up. they both get their own denominator, 2 over 20 plus 16I over 20. So when you write this, you can reduce. 2 over 20 is 1 over 10, plus 16 over 20 is 8 over 10I. And that's how you'd write that answer. 1/10 plus 8 over, that's not 8 over 20. We can go further than that. 2 over 5. They're divisible by 4. Excuse me, that would be a 4 over 5. Sorry about that. So 4I over 5. Now, number 16 is a little bit different. We don't have to multiply by the complex conjugate. All we have to do is get rid of I in the denominator. So I can actually just multiply by numerator and denominator by I. You could multiply by negative 4I, it's just adding more work. So I'm going to distribute. I get 5I plus 2I squared over 4I squared. So it's 5I plus 2 times negative 1 over 4 times negative 1. So it's 5I minus 2 over negative 4. So I'm going to clean that up. Negative 2 plus 5I over negative 4. Now each get their own denominator. Negative 2 over negative 4 plus 5I over negative 4. So when we rewrite this, negative 2 over negative 4 becomes a positive 1/2, and a positive divided by negative is going to be minus 5/4 I. And there is our answer. We'll come back in the next video and finish up this section. Thank you, and I'll see you in the next video.